Hello and welcome to today's showcase session. We're exploring one of our 8 IBC Accelerator innovation projects focused on live content moderation. As background, the IBC Accelerator program is a framework to foster agile, fast-track and collaborative innovation to support the media and entertainment technology ecosystem. Accelerators are projects that are created and led by broadcasters, studios, and other content providers who, as champions, set out their critical business or technology challenges. IBC facilitates this by recruiting a project team comprising of like-minded co-champions that are also interested in this challenge, as well as expert participant vendors, suppliers, and solution providers. They join forces, they work together to find solutions in a matter of months. Typically, these solutions would be demonstrated as proof of concepts on the show floor and through conference sessions at the IBC show in Amsterdam. Instead, we're here virtually to talk about and showcase, of course, what each team has achieved over the last few months. So this year, we have some 8 accelerator projects, as I say, and each of these teams have been working on specific challenges in areas such as 5G, artificial intelligence, computer graphics and XR animation, and VFX production workflows. This particular team, live content moderation, is a team of stellar news agencies and broadcasters. And so this team comprises the champions who are RTE, Al Jazeera, sorry. And so this team comprises champions who are Al Jazeera Media Networks, the Associated Press, Reuters, RTE, and the Entertainment Technology Center from the University of California. The vendor participants in this project are TVU Networks, TV Conal, which stands for TV Content Analytics, and MetaLiquid. So, as I say, the team has been working flat out for the last few months to prove the potential of conducting real-time AI-driven moderation for live broadcasting at scale and at speed. So they're not just looking at how they moderate live feeds from journalists in the field, but also at citizen journalism, looking at the social media channels, monitoring in real time for both regulatory compliance and editorial standards. Quite a big challenge, I'm sure you'll agree. So let's meet the team. Here we have with us today, if I could introduce you all, give it a wave. Grant Totten, who is the head of media and emerging platforms for Al Jazeera. Hi, Grant. Sandy McIntyre, VP of News for the Associated Press. Hi, Sandy. Paul Shen, the CEO of TVU Networks. Hi, Paul. Eve Bergquist, the Program Director for AI and Neuroscience in Media Entertainment Technology Center at the University of Southern California. Hi, Eve. And Julia Mora, who is the USA Country Manager for MetaLiquid. Hi, everyone. Welcome. So let's delve straight into the problem that you identified and that you are trying to solve. Why is this such a critical challenge for news broadcasters, for news agencies? Sandy, perhaps you could kick off by telling us a little bit about the challenge, and then we'll hear from the rest of the team over the course of your presentation. Over to you, Sandy.
The business challenge that we're trying to solve here is we know that more and more live video comes into the ecosystem every day. Every person who's got a mobile phone is a camera person. Video ends up on social media. It ends up, of course, also on broadcast television as user-generated content. And news people out every day shooting the news, of course, themselves create literally thousands of hours of video every year. How do we moderate that? How do we decide when video moves from camera to consumer at warp speed, what can and cannot be shown? What we know is that every country has a different regulatory environment. Every country also has a different cultural sensitivity. Time of day justifies sometimes showing an image at 10 p.m. at night to an adult audience that you couldn't show at 1 p.m. to an audience which may have children in it. So in terms of deciding what content we can and cannot show, We've got a real global problem, and that's what we're trying to solve here. So what we're trying to do here is help the humans who have to moderate this content. And we're bringing in both artificial intelligence in all its forms and machine learning to try and do it. And what we're trying to get to is a way of, in real time, interrogating the video as it comes in-house, looking at what's inside the images and beginning to get the machine to predict for us what might be coming next. Is a scene likely to get more violent? And by helping have the machine intervene, it will then get us to a point, we hope, where we will be able to effectively create an amber or red environment where if something is going from green that's okay to publish, it may be amber and questionable, and it may be headed towards red and we shouldn't publish it, but it will allow us to know that in real time, and we can then intervene as humans, as the moderators, as the people who have the ultimate responsibility, not just to our regulators, but to the public who we serve, and of course, who put their trust in us to show images that are compatible with the time of day, with the cultural environment that we're working in, and with the regulatory environment.
I'm Niamh McCull from RTE Television. Sandy has indicated a range of content moderation challenges for the industry. We have achieved some success in identifying bias and fake news, at verifying editorial accuracy, and at identifying digital rights violations. But for this accelerator, we identified graphic content as a particular concern for the news industry and the broader environment of social media content. We chose to focus on its detection, prediction, and moderation. This Reuters footage of a violent protest illustrates the kind of live-to-air material coming into our news galleries and the challenge of balancing the immediacy we value with the risk of broadcasting. Please be advised that it contains graphic content. As journalists and broadcasters, we have ethical responsibilities and standards which underpin everything we do. We have a responsibility to protect our audiences from inappropriate graphic content and the human moderators who filter that content. We have an ethical responsibility in the first instance to report with accuracy, with impartiality, and to tell the full story. We respect and work within the codes developed and enforced by our respective regulators. Each regulator in each territory compiles and enforces guidelines appropriate to its own citizens. Those guidelines can vary in subtle and significant ways according to the nuances of regional, cultural, and social sensitivities. Regulators understand and respect the influence of context, and the codes that they produce reflect that respect. The difficulty can be that in order to allow for context, hard and fast rules become unworkable. It's the responsibility of the broadcaster to interpret the regulator's guidelines and to balance the code with the context. There's also the issue that sensitivities change over time as well as geography. Both broadcasters and regulators have to be open to the continual evolution and fluidity of changing tolerances and sensitivities.
I'm Ian McLaren from Reuters. Today, live video flows through the news ecosystem from agencies like Reuters and AP onto the 24/7 news channels. For file content, this allows for quite sophisticated manual curation and signalling of graphic imagery. The metadata we apply to edited clips signal where there's nudity, sensitive language, or graphic content. But doing that through manual metadata tagging at scale on live breaking news video feeds is impossible. This requires innovation, creating an automated way to contextualize shot descriptions for graphic content, checking that data against the configured restrictions to warn and take action, allowing flexibility for regional, cultural requirements, while still giving that machine scale, and then building it into the live workflow to support the editorial teams alerting as early as possible, even predicting when content is going to become sensitive, giving critical time for the operators to react. So that's the aspiration. Over now to our expert partners who will explain the approach taken to solve this.
What's really unique and interesting about this is that the team took a radically different approach than the traditional approach to extract features from image. The traditional approach is to feed a supervised learning algorithm a lot of training examples of certain images or pieces of footage that were tagged to include graphic content versus contextually trying to represent with different signals and different elements what could be graphic content without so much supervision. The supervised learning is very robust when you have a lot of training examples and the domain that you're trying to represent does not have a lot of complexity and a lot of variance, right? So recognizing dogs from cats is a typical example. You feed a neural network, tens of thousands of pictures of dogs and tens of thousands of pictures of cats that labels dogs and cats, and they're going to recognize them. This is very different. This is a radically different challenge. This is a much more difficult challenge where you have to represent something a lot more symbolic than just an object, right? You have to represent an action and you have to represent a certain categories of action. We decided that the traditional approach of supervised learning would not work. And instead of that, the team worked on generating signals that put together would indicate that content was graphic, right? So taking as much data as we could that was contextual, not just the image, but also the audio, all of the metadata about where the footage was recorded, and try to build a more kind of hierarchical probabilistic model in the same way that the brain can put together a variety of signals into representing an action or a situation in a much more high-level symbolic way. We've really tried to generate signals from the image, from the audio, and from the metadata that could together probabilistically indicate that there was something going on that probably was either graphic content or was going to lead to graphic content. For example, where is the shot, right? Obviously, if we know where some footage is shot, if we know the date when it was shot, and we have some information that on this location, and at this location on this date, there was a riot or there was some violence, well, that's already a signal, right? If we have some visual cues about police and riot gear, weapons, fires, smoke, bodies lying on the ground, et cetera, that's obviously a second set of signals that's very, very powerful. And obviously the audio cues are also very important, right? People screaming, certain words like ceasefire or things like that would be highly indicative of graphic content. So if you start putting all these signals together, you can create a model that is very robust in the sense that it can cover and identify situations that are a lot more diverse than if we just tried to brute force this model by just feeding a whole bunch of images that were graphic into the system. This way we have a much more flexible, much more scalable, much more robust model that uses a lot of contextual signals.
Our technical contribution to this project is detection of graphical parts of the content. The objective is to fully understand the context of the image and the actual visual attributes that are associated with the potentially problematic scenes. We use object detection to localize visual attributes on the frames. So we need to identify contextual attributes such as police or protest, and identify visual attributes such as riot gears and police cars or police presence, as you can see in the video. These visual clues can be used to initialize a flag for flaggable content like this.
Our contribution in this project has been to add valuable information extracted from the video beside the static images. One of the elements we consider is detection of actions. So you can think of an action as telling something more than a simple object detected on the screen, because you can see, for instance, a firearm, or you can see somebody shooting the gun. And I guess this makes a big difference. So we thought that adding the detection of action could add value to predicting the presence of graphic content and analyze this. So in this portion of the video, you could see a bunch of policemen shooting. So we focused on this action of having the firearm and carrying it and shooting to try and identify these particular pieces of content. Sounds are important because they accompany every action. They also can anticipate violent events before they happen, because you think of a gunshot you hear before you actually see a body falling or some blood. And another important element that can be extracted from audio is the words that are spoken at some point. So these two elements are also added to our analysis. See two important elements, actually, you hear them. The first one is a burst of gunshots, and here you can appreciate not only that it's a single shot, it's actually many shots, so we can signal this as a relevant piece of indicating a lot of severity in the action. The other element that we hear are the words that are spoken by policemen. They say ceasefire, and this is again something we want to pay attention to.
Receive the content, image frames are extracted and are fed to our models to get likelihood of detecting each attribute. We used an ensemble of deep learning models to achieve a good performance. One important performance metric for our detection model is timeliness here. Here we need the minimum latency to be suitable for live content moderation workflow. Our algorithms generate image recognition and object detection results in 100 milliseconds. That would give enough time to a human reviewer to take an appropriate action. Another important performance parameter for this kind of application is the recall rate that would basically affect not missing a flaggable content. Here we need a high recall rate, although we might be trading off for some false flags. But to address that, other content attributes such as language, sound are incorporated in a secondary model, which is a probabilistic model that generates the final flag based on all possible attributes. Also, the feedback from the human reviewer decision can be fed to these cognitive models that can make them smarter over time.
So MetaLiquid has an audio detection system made of two neural networks that are able to identify different sounds in the video. So basically, the first network is able to separate what is dialogue from what is noise or from what is music, now depending on the different application. In this case, we are focusing on the noise part. So once the segments are identified corresponding to noise, we can train a second neural network to recognize types of noise that we are interested in and that are in our taxonomy. In this case, our taxonomy included exactly two elements. One is the gunshots that we saw was a very interesting predictor of a violent action. And the other one is people screaming. That again can be very relevant to identify graphic content. The action detection, we just developed a new algorithm able to improve the detection of action, so the evolution in time of an action that is actually a sort of interaction between a person and an object or between different persons. So we try to model these interactions with a graph, and then we developed a prediction system based on neural network that is able to identify these interactions specific keyframes that are flown through the streaming, and then follow the evolution and recognize what's going on. And we then train this model to recognize the action of shooting.
Advantage about this kind of more hierarchical cognitive model approach that we took is that is because of the latency, right? So a lot of the graphic content challenges happen in real time, meaning there's just live footage coming through, and then editors have to detect graphic content as it's coming through. If we're using more contextual data, for example, the camera metadata about location and time, we already can bucket specific footage coming from specific places at specific times into high risk, low risk, or medium risk pool of graphic content, just based on the fact that we know that at these locations at these times, there is violence happening, right? Generally, graphic content happens after certain signals have been expressed, for example, gunshots, for example, police and riot gear. That can also be used as a predictor in time of graphic content being, being of high risk of coming in a live feed, for example. So all of these are important, not just in creating accurate detection models directly from the video in an environment that's very diverse and where supervised learning algorithms would probably fail, but also in time being able to recognize the probability of graphic content, being able to score that probability as the footage arrives to the editors is very, very important. And so that's why we thought this model was very, very robust.
Hello, I'm Curtis Stanley, Director of Solutions for TVU Networks, and we're proud to be part of this Accelerator Challenge. Our role in this challenge is to be the video ingest point for the media and to combine our AI engine moderation toolset with our esteemed partners in this project to allow for enhanced content moderation. Users can bring media in from the field in any number of ways. Flexibility allows that incoming media can be live, recorded, file-based, or in streaming formats. For this project, pre-existing media is being used in a live format. During this challenge, as the media is brought in for review and moderation, the video is replicated and streamed to our partners so that simultaneous review could take place, as you saw earlier in the presentation. These merged scores were fed as a data stream and are shown on the preview screen as a content violation indicator and can blur or pixelate the output media. This will enable automatic content moderation in the future. While the media is being ingested, users can review the incoming material for accuracy. These previously flagged content markers are now searchable within the stored media and the UI to aid in future editing and re-airing needs.
We can now read the signals to detect and predict when graphic content will appear on a live feed. And we can pre-configure the machine to flag and to intervene so that we can blur or place a mosaic over the part of the image that could be in violation of a broadcaster standards or in violation of the regulatory environment which governs their output. The beauty of this is that the broadcaster can also dial in settings appropriate to their own cultural and regulatory environment.
Wow, fantastic presentation there. Fascinating stuff. Thank you very much. Aside from Sandy and Eve and Julia that were featured on that video, I should just give some significant recognition here to some of the other members of your team. We heard there from Neve McCall, who is a broadcast compliance specialist at RTE. We heard from Ian McLaren, who's Director of Software Engineering at Thomson Reuters. We heard from Curtis Stanley, who's Director of Solutions at TVU Networks. And we heard from Dr. Masuma Izadi, who is the AI lead at TV Conal. So thank you very much, guys. Thank you. And what a great presentation. I'll start just a little bit by asking you kind of what did you get out of this accelerator? Perhaps, Grant, if we could throw to you.
Sure. Thank you very much. I think to start off with, we've gotten a good group of friends. If I want to, get a bit emotional here, we've cried together, we've laughed together, we've, it's been great over the past 6 months. And I really think more minds can add super value. And I think really the different perspectives, Neve from RTE, for example, comes with the perspective of the regulatory side of things. We have, various angles of the technical side from the live and others. And so I think really just the different perspectives really help to create a much better solution. So I think that's what we got out of it. So.
Yeah. Paul, from TVU Network's point of view, tell us a little bit, because we heard from some of the other members of the team there. Tell us from your perspective why you think this is kind of quite a really critical area to understand and to be able to sort of automate for news providers.
Thank you, Mark. Yes, actually, just as Grant said, we started as friends. We've been talking about this for many years. For example, Sandy, we went back 2, 3, even more years, discuss about how AI can accelerate the production, reduce the cost. And during the last few months, as much as we locked at home, we have seen significant growth of the content being generated by users or by citizen journalists. One example for us, we seen over 500% growth just using mobile apps. And most of those, in the past, a lot of customers we've been working with using packs, as you've seen a lot of them. But we begin to see more and more TV stations turn to mobile apps, enable their viewers to contribute the content. Just as today environment, a lot of times they really can't send the people to the field to bring the live feeds back because of limitation on the traveling. But on the other hand, those people are no longer their own employees. Often the case, they want to make sure they've been able to properly moderate the content. As more content comes in, more content are not under the control of the traditional broadcast kind of environment. And on top of that, we also believe in one thing very important. If we look at it with today, people, the audiences has moved on. They have different devices to access to content from various different places and according to the time they want it. So very important for us to produce the content efficiently. I believe one of the big discussion what we have is not just about moderate the content. It is more the entire media supply chain. What needs to be changed? We need to move from traditional human-driven manual process to a much more efficient, automated, data-driven process. And in that, AI metadata is a critical part. I think in this Accelerator program is one of the examples using AI to driving the process, make it much more efficient. Because human reaction time and also large quantity of the live content is much more difficult for them to moderate. And so given that said, we learned a tremendous from everyone. Thank you.
Fantastic, Mark. Thank you. Grant, just coming back on what Paul was saying there, clearly content moderation is very much a human kind of based, and it's based on instincts and experience. And I think from what you showed and what the team showed there, some of that can be really harrowing and take quite a strain on the sort of mental health of people that have to filter through that. I mean, how do you think, how far away are you to think we are to kind of being able to do this and to replicate that human ability at scale and speed?
I think one of the things that came out of this accelerator with the discussion that happened and the exploration was the fact that there are nuances. And I think it's really important to understand those nuances and also, push as far as we can while respecting the human element. And I think it's definitely the human element is important, and I think we support that human element. back to the first point that you made, I really think the psychological impact of this kind, especially for the graphic content moderation, reviewers have to go through it, and just the people who actually train the machine learning algorithms, who have to go through, let's say, various training type data, it does have an impact. And looking at these types of situations, as you saw in the video. But in terms of getting it there, and I think, you know, we've come a long way, and I believe this approach that we took really is robust enough, as Yves said before, to tackle various levels of growth and configuration that's going to be needed to make this thing go live long.
Thank you, Con. Yeah. So Yves, picking up on that, a training-based approach, I suppose, has a higher chance of not recognizing unknown scenarios. Do you think this accelerator approach gives a more accurate result in that regard? How does this approach reduce the false positives?
What this does, it creates an ecosystem of signals, right? And where if you rely on a single training approach, that training approach needs to cover the entire spectrum of situations that you would encounter in a graphic content breaking news environment, which is, as we all know, enormous, right? So having a more ecosystem-driven approach where you're probabilistically inferring the probability of graphic content appearing next from a wide variety of signals is a lot more robust. And by the way, this is how the brain works, right? And this is why this is really cool from a technical standpoint, is we've really successfully replicated a major brain function in a machine learning environment. And so I thought that's very cool because it is capable of predicting graphic content across a wider spectrum of situations, which I think is the goal here.
Yeah, thank you. Paul, just coming back to you, I mean, how does your system, the TVU network system, how do you process the inputs and flag graphic content that we've been talking about specifically?
So what we have been working with a number of vendors who create the open API, and which enable any one of them to bring the metadata and the AI-driven metadata into the system. And in conjunction with our own AI system, we are able to recognize where the content needs to be marked, highlighted, or mosaic. And so we are able to create an alert for all the operators through the process, and properly processing and mark those content out, so prevent showing to the audiences.
Super, thank you. And so, Sandy from the AP, tell us, can this become a fully automated workflow, or do you think it will always need to have operators to review and to intervene to bring that human touch to it?
Well, I think actually you'll end up with having the choice as to which path to go. So for sure, when we started this collaboration, the height of our ambition was to have the best set of second eyes helping you to predict as to what was coming and to be able to help you to intervene. That was really the starting point. But what we realized as we were going through the technicalities of how we would do it, and as you've heard, the different models that we brought to bear here, and we realized that actually we could go one step further, which was to give the broadcaster or the publisher, so whether you're TV Finland or whether you're Facebook, you as the operator of that channel could have the control and you could set the sensitivities. So if you already know what your regulatory environment is, and you already know what is and isn't culturally okay at a certain hour of the day or in front of a certain audience, and you dial those in, that does give you a degree of automation to be able, as we showed in the demo, to mosaic out an offending piece of an image. But I do think you've now got the choice. For some people, the answer will be flag it, decide really quickly in a live studio gallery operation whether you should intervene. And for others, there's almost a play safe version, which is we've preset those and it will intervene. So I think we've actually created the best of both worlds here, and the ability to do it at scale across pretty much any jurisdiction from a regulatory point of view and any jurisdiction from a global news point of view. This truly is a global solution to a global problem.
Yeah, so I'll just stick with you there, Sandy, because I wanted to ask where you see this going in the future. What, from the AP's point of view, how do you see this in terms of developing into a usable, tangible kind of product that you could use? Are we far away?
I don't think so, but I think a lot of it depends now on the vendors who've come together in this experiment, because I think we've done what we said we'd do. We've created a proof of concept. And I think, and this is true, Mark, I think of all of the IBC showcase accelerators, if the vendors can then get together behind the scenes and take something that is a proof of concept and actually productize it and bring it to market, this is the world's biggest marketplace, right? And therefore, I think that the answer to that does squarely lie with the vendors. We often say inside the AP that what we don't want as we go through from a kind of innovation stage to a productization stage is a multiplicity of vendors turning up with their individual slices of the loaf. We want them coming with the whole loaf that's baked. And I think in this case, if the guys can work together, then we've got really quite a feast for the future.
Yeah, let me just jump in on this. I think exactly right. One of the very important part of this accelerator enable us to work with companies like what both TVU and Eve has been representing. Not only we bring out the product today. In fact, the TVU's product, MediaMind, actually is shipping a lot of customers using in real time. But we turn on an angle to address some of the problem what just this group has demonstrated what's important, and so we are able to deliver a complete solution to the market very quickly.
Thank you. And Julia, I'll bring you in on this point. This is the second accelerator that you've been involved in, and I think actually the fourth project I think MetaLiquid has been involved in. So you've been involved in many. What are your thoughts on how this might develop into some future potential, and MetaLiquid working with other vendors to develop what you've been achieving with this? How do you think that will play out going forward?
So we saw this as a great opportunity to get together, not only with the champions who really show us their real needs and real-time problems that we can try to solve and address, but it was a great opportunity to collaborate with other vendors. So it was overall a great experience because we really learned a lot from that. I see this as something that is really close to a product, and I guess the key point is the real-time analysis. And I would see this as an possible product for any kind of live content, even with different questions, not only in content moderation, but in general in media, in content production. It can also be pretty much with the same structure applied to other kind of questions, like for instance, generation of highlights. I guess the key here is really considering the whole amount of different information, different sources from metadata and video and audio, and put together a score or a level of interest that can certainly be a level of severity in the case of live content moderation, but can also become something else like relevance, for instance. So I would see this as a very flexible and applicable product.
Thank you very much, Julia. Thank you. Coming back to you, Grant. You've been the project lead on this. It's something you've been very passionate about at Al Jazeera. But how important is it? I mean, you perhaps could have looked at doing this on your own. How important is it that you brought other broadcasters here, particularly world-renowned news agencies and other broadcasters, to participate in this program? How important is that aspect of collaboration?
So I think, well, one aspect that's worth noting is the fact that AP and Reuters provide content to us, and we have our own content, of course. So with all of that, and plus we have user-generated content. So being able to, and then we take that and produce what we produce. But I think having the various team members from the agencies, for example, has allowed us to fast track that model and that understanding to ensure not only that our own content can be moderated, but the content that comes from the agencies can come to us in a way that also allows for that. So that's actually been really, really wonderful. And also, if a lot of this, of course, is not off the shelf. You look at some of the generic AI cognitive service type providers, and they provide it in a generic way for obvious reasons. And oftentimes, you know, if it's not off the shelf, then you need to build it. So, of course, in this particular case, this IBC Accelerator really allowed us to get the smartest people in the room and just try to, you know, knock this out and see how we can make this available. And then, like Sandy and others have pointed out, now what's the go-to market that allows us now to take this and apply it.
And also, this is interesting, reflect with what Grant just said, and also Sandy mentioned earlier, this is a global system. You know, we have customers in close to 100 countries, and the same content in a different region, actually sensitivity are different. Certain governments say, hey, this type of content you cannot be shown, but other regions, the same content is very normal. You can show. And so with the approach, with the guidance, both from Sandy and all the participant Grant, and we are able to create a metadata layer, allow us to kind of create a different alert according to the region, the regulations.
Yeah, Eve, we talked about the applicability of these proof of concepts in the other project you've been involved in, AI shot listing. How applicable do you think this is beyond news to other forms of content moderation?
Well, I think generally there's a major opportunity in the media industry overall to make that enormous mass of unstructured data that is video structured and searchable and discoverable. That is the single biggest challenge of the media industry from a technical standpoint right now, in my opinion. It's to be able to develop features, to be able to extract features from video directly from video and audio that would allow that content to be indexed and tagged with not just object level stuff, right? So we've been doing that. That's fine. But if we can try to start indexing video content with more symbolic attributes, such as, is this graphic? What action is this? What moment in the film is this? What emotional tonality is being expressed at this particular moment in the feed by the character, et cetera, et cetera. All of these features and all these attributes, I think, are the kind of the holy grail of metadata. And we've been doing a lot of work at ETC to get into that field and to step into that world. And this proof of concept is extremely exciting because it's one of the first examples that I can see of something like this coming forward and extracting very symbolic, high-level features from video and audio that isn't just a collection of APIs and stuff like that, right? It's real work. It's real unique machine learning work that has successfully extracted very high-level symbolic features from video, and that's by and large the holy grail of video metadata right now.
So I'll ask all of you kind of, where do you think we are on this journey? If you could maybe just briefly tell me where you think we are in terms of level of maturity with this. How far have we got to go? Are we just getting started here?
Grant, go ahead.
I'll come around all of you. Grant, where do you think we are on this journey? Long way to go?
I think within a short period of time, we've teased out a lot of the different possibilities here. And kind of also to leverage on the point about other industries and other use cases. Yves comes, has the experience of the motion picture side of things. You've got TV Kono that has dealt with sports analytics. So really being able to tease out, not just for the news industry or for, let's say, this type of content, but for programs and so forth. I think we've kind of dealt with a lot of the issues that have to come forth. So for this specific use case, I think we've come a long way. I think applying that, let's say, to the wider content moderation activity, whether it's integrating digital rights management or fake news detection or editorial content validation, some of those capabilities would now be sort of the next step of being able to take this beyond simply graphic content moderation. And I think the possibilities are limitless here.
Sorry, Paul, I think you were gonna
Yes, I would say just reflect what everyone said. Actually, today, if you look at something of the functionality, it's already live. A lot of our customer already begin to using those. But the long-term goal, as what we clearly understand, if we want to be every aspect can be much more efficient, human-driven, move from human-driven process to automated, still it's a long way to go. Ultimately what we want to create, it is a viewer and a content can automate creates the content. As the raw material comes in, as become the enabled media with all those AI description behind them, and with the storyline in there, I believe each of the individual can have a personalized content according to their preference, what their interests are, yet still deliver the same storyline, and yet at the same time meet the government regulations. So, this is going to be an endless long-term project. But in short term, yes, we can deliver a very effective way addressing certain of the functionalities.
Thank you. I mean, this has been an exceptional proof of concept. A lot of hard work by a lot of people here to get to where we are, and it's really impressive. Have you all enjoyed participating in the accelerators? Hopefully you have learned quite a bit from dialogue with your fellow broadcasters, from your fellow news agencies. It's quite unique to have Reuters and the AP working together here. I think that's quite extraordinary. And have you learned some new things about kind of vendor capabilities that are out there? Sandy, I'll throw that to you first.
Yeah, and I'm very glad that you picked up on that point about AP and Reuters working together, because actually the places that we have worked together historically are in the most dangerous places in the world. And one of the dangers that the media faces today is getting it wrong. Because when you get it wrong today, it echoes around the world in dangerous ways at warp speed. So I think it's great that we've come together on something like this. And I think what we've been able to do together with Reuters, with Al Jazeera and RTE, and with the vendors here, is literally let the sun rise on what is really a new dawn of assisted understanding. And I think where we're going forward is not just in creating a product that we in the news industry, I think, can use on a global scale to our global benefit. But I think in an age where inequality in our world is such a big issue, and where we as news agencies, as broadcasters, as media people need to be super cognizant of the kind of programming that we're producing, I think this will also help us in understanding bias and helping dial out bias, and making sure that we're not creating stereotypes that we didn't mean to create. So I think this really is the very start of something way, way bigger.
Could there be an accelerator project in that element of bias going forward? Could there be other spin-offs from this?
Absolutely. I mean, Yves and Grant and I have talked about this. And I think for sure, this is definitely something that we could bring to the table for another year.
Yeah. So Grant, how would you sum up your experience as the project lead in working with all these great minds on this really challenging project. And, you know, value for you at Al Jazeera, I guess, how would you kind of sum that up?
I'll start off with the time zones, if I can. Working from California, especially in these days, you know, everything's remote. I think it was beautiful starting from the London meetup where we got to physically meet up, and then just being able to work across time zones was a very interesting challenge. But I think what was great was we got really great minds from all the way from California to Singapore and the UK and Ireland. Let me make sure I get all the countries right. Florida and so forth, and the UK, of course. So having all of these different minds, it's great that we've been able to do this irrespective of where everyone is. And you know, I think from Al Jazeera's perspective, of course, we're able to now take this knowledge, take this capability and these relationships, and now take that forward. And really, with under 6 months, imagine, you know, what we get done in under 6 months. So I think that's just a great way to help push forward our capabilities, especially for areas that aren't necessarily off the shelf at this point. So it's been really wonderful for us, for sure. And thanks to everyone here too.
Yeah, I know how many hours have gone into this. So really fabulous work. And where can we find out more? So I guess your presentation that you showed earlier will be available on the project page on the IBC website for live content moderation. I think you can get in touch with any members of the team here by emailing, if you prefer, accelerators@ibc.org, and we can put you in touch with the team. If you've got any questions, of course, you can put them to the team live. So we'd like to thank you all for joining us. Really, thank you, Grant Totten. Thank you, Sandy McIntyre. Thank you, Paul Shen. Thank you, Eve Bergquist. Thank you, Julia Mora, and all the members of your team for a really fabulous piece of work. I know how much you've all put into this, so thank you. And we hope we will see you all in person at IBC next year, if not before, when business gets back to normal. Thank you so much, guys. Thank you. Take care.
Thank you.
Thank you.
Thank you.
Bye-bye.